Okay, we're here with Rita to talk about interpreting data set differences. Ready to go, Rita?
Yeah.
Okay, so when we say interpreting the data set differences, what we're really going to be asking ourselves is, what's really going on with these data? What are they really telling us about the real world? So we don't want to just look at graphs or the calculation of the center or the variability without asking us what's really going on, okay? So we're going to do this in a few categories. Let's first talk about outliers. So let's talk about a situation here about your commute to school. Let's say you and your friend both gathered some data about how long it took you to get to school. So here's your commute here. In one day it took you 8 minutes. On 2 different days it took you 9 minutes each. On another day it took you 10 minutes. Another day you also had 10 minutes. You get the idea here, right?
Yeah.
Okay. Now one thing you can see, like all of these are between 8 and 12, but one day something happened. You went to school, you were going to school, your car broke down, aliens abducted you, something happened where you took 234 minutes to get to school. It was really unusual, okay? Yeah. But that is one of your data points, okay? Your friend had a lot more kind of consistency here. They had a couple days that were at 22 minutes, and then you can see that they ranged up to 27 minutes. Make sense?
Yeah.
Okay, so now what we're going to do is, just like with many data sets, we want to compare which one of you guys has a longer commute to school, and we'll use one of the measures of center, which is the mean, okay? And remember, to calculate the mean, you add up all the values and you divide by the number of values. So let's go ahead and do that. So here we calculate the mean. We're adding up all the values up here. So we have that 8, and then we have 2 9s and 2 10s, and we add them all up, and there's 10 values here. We'll divide by 10 because there's 10 values, and we get to 32.5. So the mean of your time to school, your commute to school, is 32.5 minutes. Make sense?
Yeah. Okay,
now let's go do the same calculation down here for your friend, and we're going to go ahead and make the calculation, and we're going to get to how many minutes did it take your friend on average to get to school?
24.5.
24.5 minutes. Okay, so now we said, okay, great, we did our job, we calculated the means. So who takes longer to get to school according to the means?
I do.
Yeah, right. You take 32.5 minutes on average, and your friend takes 24.5 minutes. So that makes sense, right?
Yeah.
Kind of. But if you look at the data points, I mean, most of the time your friend is somewhere right around 24.5 minutes, right?
Yeah.
But let's look at most of the time you're way under 24, or way under 32.5 for sure, but you're also way under 24.5. So what's going on here? What do you think?
Well, we have that big number.
Right, this huge number here is throwing off the calculation. That is called an outlier. That is one of those data points that's so unusual, it's so far out of the norm that often it's useful just to get rid of that outlier and make your calculations without that. So let's go ahead and calculate the mean without the outlier. We'll do the math here. And we have all the values except the outlier, so there's only 9 of them. And when we go ahead and divide by 9, we get to the mean of 10.1. So we write that up here. The mean without the outlier is only 10.1 minutes. Now, how does that sound to you as kind of a characterization of normally about how long, if there's no aliens involved or anything like that, how long it takes you to get to school? Does that sound pretty reasonable?
Yeah.
It does, right? Because most of the time you're going to get to school more quickly than your friend, right? And we want the means to represent that. So let's go ahead and highlight what we should really be comparing here. We should be comparing the means without outliers. There aren't any outliers down here. And when we compare those, then who gets to school more quickly usually? You or your friend?
I do.
You do, right? In about 10.1 minutes on average, right?
Right.
Okay, good. So that's outliers. And remember, we're asking ourselves what's really going on with these data. We have to really pay attention to things like outliers to make sure we're not drawing the wrong conclusions. Okay, let's look at something that's somewhat similar. You have the same median, but what else can we say? So we're going to go ahead and look at 2 colleges and how many hours per week the students that we surveyed are working. So here's College A, and this is a histogram. So these are the number of students who are in these ranges. So one student only worked 0 to 5 hours. Another 1 student here worked 5 to 10. Looks like, let's see, 1, 2, 3, 4 students worked in the 10 to 15 range. You get the idea, yeah?
Yeah.
Okay. Now let's look at College B. And college B had, wow, 9 students who worked 0 to 5 hours. And you could see like only 1 student who worked 15 to 20 hours. So there's a very different kind of distribution going on here, right?
Yeah.
But if you were to look at just the median, so here we're talking about same median, but what else can we say? If you were to look at just the median, we don't know the exact values, but I think the median would be somewhere around 20 for this data set, yeah?
Okay, yeah.
And for this one, where would it be? The middle of the data.
About the same.
Yeah, about the same, right? So if we were to say, hey, the median hours per week at college A of working is the same as the median hours per week of working at college B, then we would be making a true statement, but would we be fully capturing the story?
No.
No, we wouldn't, right? Because what's happening at college A is that people are kind of clustered kind of around the middle. So most students work about 15 to 25 or 30 hours per week, right?
Right.
In college B, hardly anybody works 15 to 25 hours per week in the middle, right? Most people don't work hardly at all, or they work a whole lot. So in college B, there's a whole bunch of students who are working and a whole bunch of students who aren't working very much. And that might be a very different kind of a campus life, right, than college A, where most people are working about the same amount. And that's why we have to make sure to pay attention to what else is going on just besides the median. Okay, and then let's look at one other example. We'll use box plots this time. So here are 2 box plots that both tell a similar story, but they're also both telling a different story. Let's say these were temperatures, okay? What is the median temperature in this first box plot? Remember, the median is that middle point that's in the box there.
So like 56?
56 degrees, okay. Yep. All right, so we're saying that in this city or wherever this is, that the median temperature is 56 degrees. Now let's look down at this one. How about this one? What's the median temperature there?
It looks like 56 degrees also.
56 degrees too, right? So you could say, okay, well, both these cities are the same, right? They both have the same median temperature. But if you were to live in this city right here, you would be like, well, you know what? I don't have to wear any clothes for super cold weather that's down here or for super hot weather. But if I'm down here, I'd better have some clothes that can handle some colder weather or some hotter weather, because you can see that this variability, that's what we're talking about here, is variability, is much greater in this city than it is in this city up here. So you don't always want to just depend on the median, like in these 2 cases. You want to also look at how variable or what the distribution looks like, just like you don't always want to just have the mean unless you're taking into account outliers. Make sense?
Yeah.
Great job.